guys. In this video, I would like to present a method to convert decimal real numbers to fractions. I'm just presenting here a very simple, nice, easy example. 3.44444, which we can write as 3.4 dash. That means it's repeating by simple steps. We need to change it to 31 divided by 9. That's the aim of this video. Okay, let's go to the challenge. Just a little definition about rational numbers. This is the main idea here, the rational numbers. A rational number is an integer divided by non-zero integer. Some examples I presented here: 2 over 3, minus 1 over 8, 17 over 4, 0 over 6, 1 over 9. So integer divided by non-zero integer. This is a rational number, fraction. Now, another way we can see rational numbers are decimal real numbers. Any decimal real numbers that are terminating or repeating. So terminating, like 0.75, 3 over 4, it's terminating. There is no other decimals after the 5. Or 3.4444, 3.4 dash, which we have seen in the first slide, 31 over 9, and this is the aim of this video. How to convert decimal real numbers to fractions. I would like to present 10 examples, different examples. Okay, let's go directly. First example, question number 1, I put 3 simple numbers, x, this is a number x, 0.6, another number y, 2.25, another number z, 3.075. As you can see, there is common here between these 3 numbers. 0.6, you can just hear that, 2.25, 3.075. You can pause a little, please, if you want to try to see if you can get the fraction. We need the aim here to find the fraction that will give us 0.6, the fraction that will give us 2.25, etc. Now we notice that these numbers are terminated. See, this is the common thing here, terminated. These numbers are not repeated. So if it is terminated, we just count, see 0.6. We count how many decimals, number after the decimal point, 0.6, one number. So I multiply up and down by 10, easy. You can see that here, because 0.6 is the same as 0.6 over 1. So just wait a few minutes. This is the simple example. Now multiply by 10 up and down. So 0.6 times 10 is 6. And then over 10. Divide by 2. So 3 over 5 is the fraction. Now if you divide 3 over 5 by normal division or by a calculator, you get 0.6. Same thing we do for the second number, 2.25. 2 numbers are after the decimal point. So 2.25 is the same as 2.25 divided by 1. So I multiply by 100, up and down for sure. So this is 225 over 100, then I divide by 5. You can divide by any number up and down, divide by 2, divide by 3, divide by 5, until you get this simple fraction, 9 over 4. Now let's go to the third number, which is not repeated, 3.075 divided by 1. We have 3 numbers after the decimal point, multiply by 1,000 up and down, and then divide by 5 up and down. You get 123 divided by 40. That's example question number 1, easy one. Now let's see some repeating. 5.3333, which we can write as 5.3 dash. Second number here in the question 2, 0.45 dash, which is the same as, I'm just explaining here, 0.45454545. It's repeating, never ending, not terminating. So let's take the first number. You can pause here also a little. How can you get 5.3 dash? See the dash on the 3. 5.333333. We need the fraction equals to that. You can figure it out. You can think. You can do something. It's not easy here to multiply up and down by 100 or by 10 or whatever. You have to do some nice method. Let me show you the method here. Now, there is one repeating number here after the decimal point. We can have 2 repeating numbers. We can have 3 repeating numbers. So let's call this number x. So start by letting the rational number equals to x. So every number repeating is rational. So there is a fraction. So let x equals 5.33. Since I have 333, which is one number repeating, I multiply by 10 on both sides of this x. You see this x here. Let x equals 5.33. Multiply by 10. Why 10? Because one number is repeated. Now, as we can see in the next example here, B part 0.45. So we expect to multiply by 100. Now, so I have now 2 equations. This is an equation, x equals 5.333, and then another equation, 10x is equal 53.33. Let's subtract the 2 equations. What I mean by that, left side 10x minus x, I can do that. Then 53.3 dash minus 5.3 dash. Why I subtract? To remove the repeated part. Look here very carefully on the right side here. On the right side, 53.33. Even if you subtract on your paper, 53.33 minus 5.33, you cancel out all the repeated part. You are left only with 53 minus 5, which is 48. So now we have nice, easy fraction. 9x, because 10x minus x is 9x, is equal 48. Now x will be, this is the number we need, 48 divided by 9. Just simplify it. Always you have to simplify it. Divide by 3 up and down, you get 16 over 3. This is the fraction we need. I think it's interesting here to check the other number here. You can try now 0.45454545. Let's see. Since I have 2 numbers repeating after the decimal point, so I multiply by 100. So 100x is equal 45. I move the decimal point 2 places. 0.4545 still repeating, still always. Subtract now, directly I put here, 100x minus x is equal 45.45 dash minus 0.45 dash. So I remove all the repeated parts. So I get 100 minus 1 is 99x equals 45. So x is equal to 45 over 99. Divide by 9 or simplify it. You have to simplify it any way you like until you get 5 over 11 is the fraction equals to 0.454545. Now I will go to higher level now, little more difficult question. Question number 3, little tricky. I put here 2 numbers. Both of them are a little tricky. Let's see, 10.16 dash. So this is 10.16666666. So the repeated part is 666, but there is one after the decimal point not repeated. So we cannot use that method, which I explained in question number 2. Also here I have in the second question here, second part in question 3, 3.01, two numbers after the decimal point, not repeated, then two numbers repeated. You can have all kind of these numbers, decimals that are repeated, but we know that these numbers are fractions. So we are hoping to reach the fraction 10.1666666 or 6 dash. Let's go to the first one. As you can see, I have to remove the 1 first. You see 10.1. I have to remove the 1 from the question. So I multiply, let x be the number itself, 10.16666, multiply by 10 only first. You can see that here, first line in equations, multiply by 10. So I get 101.666, which is 6 dash. Let's call this equation U. Okay, now this is like question number 2 now. I have 101.6 dash. So I leave now the x. I leave the x completely. I work with U, equation U. Since I have one number repeating here, 66666, I can multiply equation U by 10 again. So that will be 100x equal 1016.6 dash, and then I would call this equation W. You see the idea? I have a number after the decimal point, not repeated. I have to remove it to the other side, so I multiply by 10 if it is one number. If it is two numbers, I multiply by 100. Then after that, I see the repeated part. So I subtract now, let's see, W, you can see here, right? W minus U. See, I don't use the X now in this question. 100, see the 100X, which is W, minus 10X, which is U, is equal this minus this. So 90 now, 100X minus 10, 90X is equal 1016.6 dash minus 101.6 dash is equal 915. So now we get X here. 915 divided by 90. So the first I can think of is divide by 5 up and down. So I get 183 divided by 18. Divide by 3 again. So I get 61 over 6. Nice fraction. 61 over 6. This is equal to 10.1666666. Can you try the second one, please? If you like. You can pause the video for a little and try 3.01262626262626 repeated forever. Now let's look at the second part of question number 3. Here we see 3.0126 dash. We see two numbers after the decimal point not repeated. So let's call the first number, the original given number, let's call it X. So let X equals 3.0126 dash. Let's multiply by 100 because we need to get rid of 0 and 1 in after the decimal point. So I multiply by 100, I have now 100x is equal to 301.26 dash. Let's call this equation T. So now we have new number, 100x is the number, is equal to 301.26 dash. Now the repeated numbers are also 2 digits. So I multiply by 100 again. So 100x times 100 is equal to 10,000. 301.26 dash multiplied by 100 becomes 30126.26 dash. This is equation K. So let's find equation K minus equation T, which is 10,000x minus 100x is equal to this number minus this number, which is 29,825. We cancel the repeated part. So now x will be 29825 divided by 9900. Divide by 25 up and down, we get 1193 divided by 396. Now we will see a very strange number where we have a sum of two numbers repeated. Both are fractions. 4.111111 plus 3.05555555. We need to add these numbers. The sum is equal A over B. We need to find the values of A and B. That means we add the numbers and change it to fractions. Simple. You can do it any way you like. You have more than one method. Here I will present two methods. Choose whatever you like. The one is easiest for you. Method number one, we can add the numbers and then we convert to fractions. So I just write 4.111111, 3.055555. When you add the repeated parts, it will be all 6, and then we have 7.16 dash. We have seen this example similar in, I wrote here, in question number 3, part 1. You can see, same method, 7.16 dash. Same method, different numbers. So one number after the decimal point, one number is repeated. You do the same method, you will get 43 over 6. Or another way, maybe you can think of it this way, you can convert each number to fraction, then add. So I take 4 point, if you like this method, 4.111111, see question 2a. See, there's one repeated number here. Same method, question 2a, you get 37 over 9 for this number. 3.055555. So there is a 0, one number after the decimal point, then repeated one number. That will be question 3, first part. So that will be 55 over 18. Now you add 37 over 9 plus 55 over 18. You need LCD here. 18, then you divide by 3, you get 43 over 6. So A will be 43 and B will be 6. Now the nice number, the last question here, look at this heavy repeated decimal number. 7.285714, 285714, 285714, 285714, so on until infinity. So repeated part here, 6 numbers, 285714. Then it will repeat again. So we can have as many numbers as we want in the numbers, the repeated numbers. Not only 2 numbers like 5.26, 1.555, 3.0101. We can have all kind of repeated decimal numbers, which are fractions. So we need the nice fraction equals to this. I advise you personally, stop the video now for a minute, pause it. Try this number here. Tell me the fraction equals to 7.285714 repeated so many times until infinity. Have a challenge and tell me this number. Okay, I think you get it now. Let's see, how many numbers in the repeated part here? We have 6 numbers, 285714 repeated. So I multiply by 10 to the power 6, which is 1 million. And then directly I subtract million x minus x, and then 7285714 point, the repeated part, minus 7.285. So I get 999,999x is equal to 7285707. And then divide this number by 999,999. You need to use a calculator here to simplify the fraction. The fraction we need is 51/7, believe it or not. 51/7. I put here some nice hint if you need to, when you simplify it by a calculator, divide by 11 up and down, divide by 13 also, divide by 27, then divide by 37. Takes time to simplify it, but this is a nice example. Now, usually I put here some practice questions for you to do. Convert the decimals to fractions. Very nice numbers. Look at the numbers here, 1.48 and 1.48 dash. So what is the difference? In E, it is terminated. There is no repeated. You can see question number 1. Y equals 1.484848, repeated two times. And then practice number 2, 0.787878, etc. And number B, 1.4, and then repeated the 3 one time. While practice number 3, there is a sum, 0.54 dash plus 2.045 dash is equal m/n. Find m and n. You can find the sum similar to question number 4, I think. And then the answers here, I put the answers, EY, AB, m/n. Okay, thank you for watching. I hope you enjoyed the video and you get some benefit. And I hope I can see you in another video, another topic. Thank you very much.